be doing lesson 2.1, the first lesson of Unit 1, which is graphing quadratics. So, a quadratic can have a minimum or a maximum, never both, okay? And that minimum or maximum will always be the vertex, okay? So, the quadratic function will either open upward and look like a smiley face, that's when your a value is positive, or it will open downward and look like a frowny face, and that's when your a value is negative, okay? And just like with absolute value functions, when your absolute value of a is greater than 1, that's a vertical stretch. If the absolute value of a is less than 1, it's a vertical compression. So, in order to graph in vertex form, the first thing you want to do is ensure that we are in vertex form. That's what vertex form looks like. You're going to have some binomial squared times a, unless a is 1, of course they won't write it in, plus k, or it could be minus k. Or k could not be there and it would be 0, right? So you're going to plot the vertex, you're going to find the vertex, plot the vertex, and you're going to make your table, okay? With that table, you're going to backtrack and forward track values, so I'll explain what I mean by that. And then you plot 5 points, and that's basically the main idea of it. It's pretty easy. So, step 1, we're going to identify the vertex looking at this equation. So, just like with the absolute value equations, your vertex, h is always going to be the opposite. So in this case, it's going to be negative 5, comma 2. So the h is always opposite sign. The k is as we would expect it to be. Okay, does anyone have any questions about that? The axis of symmetry is always x equals whatever the x coordinate of your vertex is. Now, one of the most common things I saw people make mistakes on that test is just putting negative 5. The axis of symmetry is an equation. It should not be a value, so you lost points if you don't put x equals. We are going to see a lot of axis of symmetries in this class, so please make sure you get in the habit of writing an equation, not just a number there, okay? So, next thing we're going to do is you're going to put your vertex in the middle of that table, okay? The vertex will always go in the exact middle of that table. Now you're going to find two values that are less than negative 5 and two values that are greater. And you can go like by 2's or you can just go by 1's. Usually I'm going to go by 1's. And they have to be equidistant. So negative 4, negative 3. Oh, I meant to put it the other way. Hang on. I don't know why I did that. You could do it that way, but I'm going to go small to big. So negative 7, negative 6, negative 5, negative 4, negative 3. Okay? So the thing about quadratics is they have symmetry. So you actually only need to find 2 extra points to find all the points. And I'll explain what I mean by that. So step 1 is going to be to graph the vertex. And then you're going to draw the axis of symmetry through the vertex like this. Okay? Now, we know that there's symmetry across that axis of symmetry. So we only need to find 2 of the extra points, and then we can mirror them over to the other side instead of finding all 4 algebraically. So I try to pick the points that are going to give me positive numbers to work with, but either one is going to work. So I'm going to use the negative 4 and the negative 3, and I'm going to plug those values into the function. So I'm going to start with negative 4. I'm going to plug negative 4 into my equation. So we always do order of operations, parentheses come first. What's negative 4 plus 5? Good, 1. What's 1 made negative? Good. What's negative 1 plus 2? 1. So we have a 1 here. That means we also have a 1 here because there's always symmetry here, here, and also here. Okay? So we can go ahead and plot. Yes? You not square it? I did square it. I squared this part. So you square before you multiply by the negative 1. So we get negative 6, 1, and then we get negative 4, 1. And now we need to continue with it. So to continue, we are going to plug in the negative 3. So we plug in a negative 3. We get negative 3 plus 5 squared plus 2. What's negative 3 plus 5? 2. Good. What's 2 squared? 4. What's 4 made negative? What's negative 4 plus 2? Not 2, but negative 2. So keep in mind, guys, when you're doing this, if you are still struggling with your order of operations at this stage in your math career, if you literally take one of those calculators and type this in exactly as it is, that calculator will do the order of operations for you, okay? So keep that in mind. I'm not going to be spending a ton of time explaining to you order of operations because that's a prerequisite skill. However, we have the tools in this class that require you not to have to do it on your own, so you can use the tools that we have to do it for you. So this is going to be a negative 2, which means this is also a negative 2. So I plot those points, which I did, and then I can just connect them. And once you connect them, we're ready to identify the key features of the graph on the right there. So the cool thing about quadratics is the domain is always negative infinity to positive infinity. The range is always whatever it starts at or comes up to, okay? So the range is going downward from negative infinity until it gets to what y value? What's the highest that this goes? Very good. And 2 is included, so we're going to use a square bracket. So that's all review stuff. Now, notice the y-intercept. See how we don't cross the y-intercept in the picture of our graph right now? But this eventually will cross the y-axis if we keep going. It's going to get wider and wider. So we have to figure out where it will cross the y-axis. So how we do that is, anytime in math, you want to find an intercept. If you're on an SAT, you're on a test, whatever it may be, you plug in 0 for the opposite variable, okay? So if we're looking for a y-intercept, we want to plug in 0 for the x. Good. So we're gonna plug in, we're gonna take our function and we're gonna plug in 0. And like I said, you can do this mentally or on the calculator. You don't have to write this out every single time. I'm just writing it out for the sake of teaching you. So what is 0 plus 5? What's 5 squared? Good. What's 25 made negative by that negative out front? What's negative 25 plus 2? Negative 23. So that means we have a y-intercept at 0, comma, negative 23. So if we were to keep graphing more and more points on our table, we would eventually get a y-intercept at 0, comma, negative 23. Now, is the vertex on this graph a maximum or a minimum? A maximum. And it's at what y value? Good, at negative 2. And now we're going to just talk about transformations. Oh, sorry, it's positive 2. Thank you. Sorry about that. So, if your graph is a frowny face, that means you automatically have a reflection over the x-axis. Okay, if it's a frowny face, that's the first thing you should write down. Okay, everybody can get that easy point on the test. Now we also want to look and see where it's been shifted from the origin. So how many units has this been shifted to the left from the origin?
Negative 5.
Very good. So we went 5 units left. And how many units up did we go? 2 up. Alright. So pretty easy, right? It's pretty similar to absolute value in terms of identifying key features. Alright, so we're going to skip number 2, because everybody was so good paying attention to that. Okay? And everybody seemed to understand it. And we're going to go right to number 3. So, this is the other type of question you're going to have to learn about in this class. You are sometimes not given vertex form. Sometimes you're given what we call standard form. Does that look familiar to you? It should. Ax squared plus bx plus c. You hit this hard in algebra 1. Okay? And if you didn't feel like you learned it very well in algebra 1 for whatever reason, we're going to still go through everything. Okay? From the top to the bottom. I'm not expecting you to really remember anything from it, but it may look familiar. So, standard form is this form. And we graph it, and the process is a little bit different. So, in order to be in standard form, you need to be in descending degree order. So the x squared term, then the x term, then the constant. If it's not in that order, you need to rearrange it into that order before you proceed with anything else. Now, since we can't just look at this form and identify the vertex, we actually have a little formula called the axis symmetry formula, which is x equals negative b over 2a. This formula allows us to find what the axis of symmetry is. Once we know what the axis of symmetry is, we know that the axis of symmetry is the same thing as the x-coordinate of my vertex. I can then take the x-coordinate of my vertex, plug it into the function, and find the y-coordinate. In addition to that, what's really cool about this form is this is exclusive to only this form. It does not work for vertex form. Okay, I know somebody will think the opposite in the future. I'm just going to be clear. That c value is the same thing as the y-intercept. So you don't always have to algebraically find the y-intercept with this one because it gives it to you, unlike vertex form. Alright, so let's go ahead and try the procedure. Now I also want to mention negative b over 2a. What that means is whatever your b is, it's going to change sign when it's plugged into the formula. Okay? So let's do an example together. So, who thinks this is in standard form? Raise your hand. Who thinks it's not in standard form? Very good. What's wrong with it?
The x squared is in the middle of the sentence.
Yes. And anybody want to tell me how to fix it? Yes. Harsh.
4x squared first.
Good. 4x squared minus 8x plus 1. So the reason that's so important is because the formula is important to be in the right order. And for many things that we do with quadratics, you have to be in that form, standard form. Okay. So now that you've rewritten it into standard form, we're going to use the formula to find the axis of symmetry, which is x equals negative b over 2a. That's x equals. When you plug b in, it's always going to flip sign. So if it's negative, it's going to become positive. Had it been positive, it would have become negative. It's always going to flip the sign. Then we have times 2 times 4, okay? Which gives me x equals 1. Does everybody see how that's x equals 1? Oops, I meant to write that up here. Hang on, sorry. So the axis of symmetry is x equals 1. The vertex is 1 comma something. It's always the axis of symmetry for the x, and then we have to go and find the y. So here's how you find the y-coordinate of the vertex. You take what you get for the axis of symmetry and you plug it into the function. And it doesn't matter which form of the function you plug it into, you're going to get the same answer either way. I'm just using the standard form here. So, what is 1 squared?
1.
Good. What's 1 times 4?
4.
Good. What's 4 minus 8?
Negative 4.
What's negative 4 plus 1?
Negative 3.
Good. So the y-coordinate of my vertex is negative 3. So I can go ahead and plot that right here. Now I need to get the rest of the values in my table. So I go backwards 2 values, and then I go forward 2 values. And remember, these match, and these match, which mean I only need to plug in 2 of them. But here's something really cool about this, okay? We can also identify the y-intercept. What's the y-intercept based on the c? Good, it's always 0 comma 1, remember? X, y. So we can plot our y-intercept at 0, 1. So, do we need to plug anything in for 0 here? It's 1. It's already 1. I don't have to do any math. Does everybody see that? My y-intercept was already 1. I don't have to plug it in. If you plug it in, you're going to get the same answer. Which means that what else is also 1?
2.
Good. All right. Now, I'm just going to tell you because, it's save time. These would both come out to be 13. If you do the math, you'll see that. See how 13 doesn't fit on this graph? So for that reason, we're only going to plot these 3, and then we're just going to estimate. Does anybody want to raise their hand? Don't shout it out. And tell me, you don't even know what the question is yet.
I want to raise my hand.
Does anyone want to tell me why you think this graph is so stretched out?
I think he knows.
Go ahead, Jackson.
It was vertically stretched.
By what by what factor?
The slope.
No slope in
8.
there. 4. Why is it 4 instead of 8? Because 4 is the
It's the thing for the x squared.
Yes, it's the A. Good.
What in the world?
Okay.
This doesn't
A
Alright.
is the slope.
What?
A is -8.
Um, no.
Sorry.
It's positive 4.
If it was -3.
Where did you get A from?
It's the number in front of the x squared.
Oh, I was looking at the first equation.
Oh.
And now I know why it's so important to. That's why I
See?
said 8.
You see?
Yeah, I see now.
See why I harp on these things? Okay.
It's very
Does any
smart of you.
I know, it is very smart of me. So, does everyone understand the range? How I got it?
Yes.
Good. Does this graph have a maximum or a minimum?
Minimum.
At what value?
-3, 1.
Okay. Does anyone have any questions? Technically, it'd be 1, -3, but yeah. Does anyone have any questions before you start the homework?
No.
Okay.